Hello and welcome. So we're going to look at algebra now, and we're going to do over the next few weeks of lockdown, we're going to do a small algebra course, a kind of introduction to algebra. We're going to look at a whole bunch of different things. So we're going to start this week. We're going to look at, we've got 4 different lessons. We've got what do the letters mean? How do we simplify algebra? Let's distribute. And then we'll look at giving meaning to distributivity. Okay, let's have a look with and start here with this quick question. Can you name the 4 operations? Okay, you've probably heard me say that in class. You use the word operation. Do we remember? Yeah, we're talking about addition, subtraction, multiplication, and division. Okay, those are the 4 operations. Now, there is an order to operations, as we've seen before. We multiply and divide before we add and subtract. So, for example, if I told you to do 5 plus 4 times 3, the correct answer would be to do 4 times 3 first. So 4 times 3 is 12, and then we do 12 plus 5 is 17. What we wouldn't do is do 5 plus 4 first. Okay, so you remember this is the order of operations, and it's that key idea that we multiply or divide before we add or subtract, and they are a higher priority operation. What if you wanted to add first? Then how would you represent that? You could use brackets. So for example, if I wanted the person who's working at this sum to add the 5 and the 4 first, we would need to signify that with brackets. And it's really important that you understand just why we have brackets. The function of the brackets is to tell us to change the priority of the operation. So in this case, we're saying, please add first. Please do this first. So we can think of this as a function machine. So let's imagine we put 5 in here into this function machine, and I think at this point I'm going to bring my screen on. Okay, so we've got this function machine, and what it does is it takes a number, it times it by 3, and then it adds 2 to it. Okay, so if I represent this here, there we go. Right, so let's imagine what we'd get if we inputted 5. So if we put 5 in there, we'd be doing 5 times 3 is 15. 15 add 2 is 17. Okay? So I'm hoping you're getting this idea that I've taken that 5 that we can see on the screen and put it into the function machine. What if I put 10 in? I could put 10 into my function machine. That would be 10 times 3 is 30 plus 2 would be 32. So what we have is we've got something that goes in, which we're going to call an input, and we get something out of the machine. We get an output. Okay, and the machine is really just a set of instructions, times by 3 and add 2. And again, we could represent this as saying, okay, we take the number 10 times 3 and we add 2. And that's really what we're doing with that function machine. Okay, you can see I've put an example up on the board there of a negative. We've got negative 2. So let's do that. Negative 2 times by 3 would be negative 6. Okay, sort of write that there. Oh, so you can actually see. And then we're going to add 2 to that, which would take us to negative 4. So again, you can see we've got all these different inputs and we get all these different outputs. Okay, I'll leave that out of the way. Okay, and again, we could do different function machines here. We've got minus 2. We want you to minus 2 away from the number, and then we want you to times it by 7. You could imagine having lots of different function machines. Okay, so let's have a look at this. This would be an algebraic function machine. We've got n times 2 plus 3. Okay, so let's write out exactly what's happening to n. Okay, so in this case, we start with n, we times it by 2, and then we add 3 to it. And I'm going to show you how to represent this. When you times an algebraic term, like a letter, by a number, we can just write it like this, as 2n. Okay, so if I've got n, and I have two lots of n, I have 2n. And so this entire expression would be 2n plus 3. And again, that's what this means. It means take n, times it by 2, and add 3. Okay, let's have a look at a different one. Oh, yeah, so this is me writing out here on the board as well. Okay. Let's have a look at this example. So here we've got n times 5 plus 10. So let's write that out. That's going to be 5 lots of n plus 10. 5n plus 10. Okay, and again, it's important that we understand what this means. You can think of what this means as we take this number, our input, we times it by 5, and we add 10, and we get an output. Okay, that's really what this is telling us to do. Let's look at this slightly different example. N plus 3 times 2. So what's crucial here is we want to add 3 first. So for that reason, remember, we multiply before we add. So if we want to add first, we're going to have to make use of brackets. Okay, so the way you would explain this would be n plus 3 in brackets times 2. Now, if you want to times this, a bracket times 2, we can just put the 2 in front of the bracket. These two things mean the same thing. So this is just a bit of algebraic terminology that we're getting used to there. I'm just going to move this out of the way. Okay. Okay, so we need to have a look at this. Sammy and Gail have each written down an expression using the variable a. So Sammy has written down a plus 2, and he says that his expression has got the greatest value. In other words, it's bigger. He's saying a plus 2 is bigger. Whereas Gail's saying that her expression has the greater value, and her expression is 2a. The question is, who do you agree with? So maybe at this point, pause the video, have a little think. What do you think is bigger, a plus 2 or 2a? Okay, so let's have a little think. A, but remember, is a number. So we don't know what a is worth, so let's just come up with an idea. Why don't we pretend that a was 1? Okay, let's say a equals 1. What would Sammy's expression, what would a plus 2 be if a was 1? It would be 1 plus 2. Yeah, notice how I've just replaced a with 1, so that'd be 3. What about Gail's expression? What about 2a? Well, 2a would be 2 multiplied by a. In other words, 2 times 1 equals 3. So if a is 1, then actually, oh, sorry, I put 2 times 1 is 3. I've added there. That should be 2. 2 times 1 is 2. So if a was equal to 1, then actually Sammy's expression is the largest one, isn't it? Because 3 is the bigger number of these two. Let's imagine if a was 10. Okay, I'm just choosing random numbers here. What would a plus 2 be? Stop and have a little think. What do you think a plus 2 is if a is 10? It would be 10 plus 2. It'd be 12. What would 2a be equal to if a is 10? That'd be 2 times a, which would be 2 times 10, which would be 20. Oh, but in this case, it's Gail who has the largest number, whereas in the first example, it was Sammy who had the largest number. So that's your answer. Your answer is, we don't know which expression has the greater value. It depends on what the value of a is. If a is 1, you're going to get a different answer than if a is 10. If a is a negative number, that would change things as well. If a was 0, that would change things. So it's just one of these things. A could be any number. We don't know what the value of A is. So what A actually equals is going to have a big impact on what, for example, A plus 2 actually was, or what 2A actually was. Okay. So here are some examples that I want to go through. So what I'll do is I'll put this back up and we'll go through some of these examples here. Okay, so what I need you to be able to do is tell me what A plus A is. So A plus A is equal to, well, let's think. Let's represent A like this. If I've got a box and I add another box, I have 2 boxes. Okay? B plus B plus B. If I've got a circle and a circle and a circle and I add them together, I have 3 circles, 3B. 4 times T. If I've got 4 lots of a rectangle, if I'm saying I've got 4 rectangles, 4 lots of rectangles, or 4 lots of T, I've got 4T. So 4 times T is 4T. Okay, let's do this next one. Let's do Q times 8. Q times 8, well, that's the same as 8 times Q. Okay, multiplication is commutative. Multiplication, by that I mean these two expressions are equivalent. Q times 8 is the same as 8 times Q. You can do that in maths when you multiply numbers together. One number times another, like A times B is the same as B times A. 5 times 3 is the same as 3 times 5. Q times 8 is the same as 8 times Q. So this would be 8Q. Now it's important to note that we always write this number here in front of the letter. So we put 8Q. We would never write something like this. We would never write Q8. Okay? Let's have a look at another one. We've got C times D. C times D would be CD. The take-home message here is, with algebra, if we're timesing 2 algebraic terms together, like C and a D, we don't need to write the multiplication. We just save ourselves a bit of time, and we're just going to say that CD just means C times D. Okay, I'll make that a bit more concrete rather. So C times D, let's pretend we're doing 5 times 4. Okay, so we're told that C is 5 and D is 4. We would just say that's going to be equal to 20, and so CD in this situation would be 5 times 4 as well. Okay, so if all we were given was that, we would just know to do 4 times 5 is 20. Okay, another quick thing, we write the letters in alphabetical order if we're putting them together. So I'll adapt the next question. So if I do C times A, if I'm doing C times A, I would write my answer as AC. Okay, so I put the letters together, but I've written it in alphabetical order. What I don't do is write CA. Okay, I would write it in alphabetical order. And the reason we do that is once we get more complicated algebraic terms, it becomes beneficial to have it in alphabetical order for a bit of ease. Okay, so what I'm going to do now is put some questions up on your screen, and I want you to answer them.